All right, welcome back to another lecture on Python. So today we're going to talk about um, input and output. Um, that's usually shortened to I/O. You'll see that all over the place. You've already, if you've been watching these lectures, you've already done a lot of the O that you would do, which is printing to usually to the command line. You can see, and from our last lecture, I have quite a bit of O, numbers and bits of text and stuff like that coming out to the command line. When you're working in a program, that's often like when people refer to I/O, it's usually referring to things coming in and out, or stuff coming in from various places on your computer, and O being usually log files or outputs to a console. I/O is actually one of the slowest things that you do in programming. So you generally, if you do start writing, sort of big code packages and things, you should always be considering how frequently you're sort of slowing your program down to print something to the screen or read something in from another place. It takes magnitudes longer to print something to the console than it does to store a value to a variable or something like that. So you're about to learn about the slowest part for programming, but also the most important part. So first of all, I'm gonna make a new file in my little Python teaching repository. I'm gonna make a Python file. I'm gonna name it io.python. And it's going to ask me if I want to add it to my Git repository, and yes, I do. First thing I'm going to do here is copy over my little explanation, my little documentation from the old. Did not mean to click that. Copy over my documentation from the old file so that if anybody ever uses this, or if I look back on this, I know what it is. And we will say io.py shows how to do various kinds of input and output operations in Python. So first of all, I'm just going to print something so that we can start off strong. We're going to say this is console output. And as we've seen, this is very easy. Boom. So console cleared. We have a nice little print here that says this is console input. Excellent. So next thing, the first new topic here is your question might be, how do I make my Python code interactive? Or how do I make, maybe you need something that you want to wait for somebody to be there to make it run. And the way you do that is with your first I. So we have our O, which is output, printing, and now we're going to do an I. And we can do that with raw input, which is a Python function. Ooh, should be. Maybe that's an old function. Oh, is that just input? So this is a good use of the IDE here is the IDE gave me this little red light bulb, and it said, it gave me some suggestions of things to do here. Let's see. Your type a line of text and press enter. So when you take an input, the first thing you'll want to do is you put a prompt here, some text, and then you want to tell it what you're expecting to store, and what you will store it to. So we will use our nice var1 equals, for now we will just put an empty string, and we will say var1. Did I use this wrong? Let me double check here. So this will give me, if I mouse over this, it will show me some documentation. And let's read the string from standard input. The prompt string, if given, is printed to a standard output. So, where is it? We'll give you an example as well here. Show me more. So this is a good example right here of how Python, or how it's nice to use an IDE here. So right, I couldn't quite remember the syntax here, and no matter how familiar you are with programming, you always, at least I always periodically forget specific syntax. But PyCharm is nice enough to recognize that I'm trying to do something and refer me to the spot that it thinks I need to look at in the documentation. And this is just Python's documentation. And you can see right here, this is the input function that I'm trying to use. And see, this is my issue. I thought that you put both things in, or that you wanted to use in the argument of the input function, but you actually only put the prompt in the argument. And then you tell Python that the output of that input function is going into your variable. So knowing that here, I will say, let's clear this out. And we will say var1 equals. So now I have that all smashed into one line, and we can try to take our first input and then print it back out. So how are we going to print it back out? Obviously, we're going to use the print function. But I'm going to do something a little bit fancy here and say print you typed. And this is always a good thing to do if you are writing code, because you make typos a lot. You might read something in and do some sort of manipulation and find that your manipulation isn't doing what you think it's doing. So it's always good to verify anytime you take an input what you actually get as input. So there you go. Now we can continue. So let's hit play on this file, and you'll see this is the console output, and then it says type a line of text and press enter. And then it didn't do anything else, right? Because it's waiting for me to type my line of text. Text here. So in and then I hit enter, and then lo and behold, my code has spit me out the text that I typed. Just like when you're defining variables in the you can take numbers this way, you can take text this way, just like when you're defining variables in your other parts of your code. I like, by the way, I don't think this has been mentioned yet in the course, but Python, you can skip lines as much as you want. It doesn't care. When it reads the code, it just moves past them. The other thing Python does is it jumps over spaces when you're doing math. Python can be, most coding languages ignore white space entirely. Python actually is a little bit picky about if you put white space at the start of a line, because it has certain times that it wants code to be tabbed, and we'll see that very shortly in the course. But so at the start of the line it will be picky, but most other places in Python code it will just skip white space like it doesn't exist. So you'll see that I like to put spaces between my operators, like my equal signs or my plus signs, because I think it makes it more readable. But there you go. You can now IO in Python. But this is only one form of IO. And it is, in fact, in my opinion, the less useful form of IO. So the obvious next step is this IO that you've done is what's called sort of cached or temporary storage. So when this Python script prints something out, it only prints it out to the console, and when that console is closed or cleared or you run a new script, that text is gone forever. And likewise, when you input this text that you entered here, it's doing it live. It's reading this text in and storing it in this variable, and sure, you can use it in the rest of your code, but once that text, it requires me to be here to enter something, and once your code finishes, it clears this variable and initializes it back for the next line of code, or rather the next time you run code. So the obvious next question is, how do I store something or save or read something in or store it more permanently? Say if you wanted to read a bit of text in from a different file on your computer, or if you wanted to save outputs of your code to a log file, or save the result of your hour-long calculation. Well, that's the second half of IO. So let's start with, I think personally, I think it's a little bit easier to understand writing something in Python, but we will start with opening a file. So when you do this all the time on your computer, but it's a little bit weird to think about the specific operations that are required to actually get a file into memory, managing that memory, and then releasing that memory. These are things that your computer generally does for you, and you don't really think about them. So when you get to start coding with using files as input and output, it really it makes you pay attention to these sorts of things, because you can't just assume programs generally don't just assume what they're going to do at these specific points, like normally, like you'd see normally with a computer. So first thing we have to do if we want to open a file is we have to tell the computer, or tell the program and the computer where it is. When you need to tell the program or the computer where something is, there are two different ways to do that. When you run your program, it opens this little console here and does something, does calculations. But anytime you run a program, there is an associated spot on the machine that it is running that program. It needs to do, when it allocates memory for variables and things like that, it actually has to do that in a location in memory. And it has to, load your py file out of a location on the computer. You can set your program to run and start from different locations if you want. And your first option is you can reference whatever file you want to read in or create locally, which means from that from that program's running location. So if I ran this program in my Python teaching folder, then I could reference everything without the rest of this file path. I can reference things with that dot notation that I had pointed out in a couple lectures, a couple different lectures. But the sort of safer way to reference things is to do it globally. This requires that you specify the entire path to something. Path meaning like the specific set of files that you need to reference to know exactly where that file is stored on your computer's hard drive. And that's what I'm going to do mostly for the course. Actually, if I want to make this so people can download it, maybe I should. So this is why you have to consider which method you want to do. I'm used to working on code that runs on my machine, and it is safer to sort of reference things globally if you do that. There's less room for accidentally referring to a spot or file that you didn't mean to. But considering I was sort of writing this code so that everybody could download it, we actually should probably use a local reference to what we're doing. With that all being said, let's open. I have a text file right here that I put in this directory, in the same directory as this io.py that I've written. And let's open that text file. So file dot. So I'm telling Python that I'm going to use this file sort of data structure, and we're going to open, and then it will ask me for, so we're going to run into this syntax thing again. Really? That should be built into Python. I'm pretty sure it is. One moment. So let's do dot slash. So the dot means the current directory you're in. The slash means you're inside of that directory. Test.text. And does it in file equals, oh sorry, I got a little bit C, I put a in C-based languages you put semicolons at the ends of lines, and I got pretty I did that. So I put this dot slash here. Technically, I probably don't need it. The assumption generally, if you don't put any reference to your current directory in, is that it will load from the current directory. It will look for file names of this format and try to load them. So it doesn't like that syntax. Anyway, open here, I can always verify it turned blue, which means that the IDE recognizes this as a function. And let's see what they recommend. And I will show you this. So you can read the documentations for open. You will see there's a lot more options for this, and the reason that there's a lot more options here is this open function is actually quite powerful. Sure, we're going to mostly be using it to read text and write text. That's probably its most common use, but you can also read things that are in different formats. You can read binary files, which are usually like executables. You can read files with what's called buffered memory, where you're sort of only loading in bits and pieces of the file as you go. You can change the encoding, which sort of modifies. Encoding is sort of the code for taking a bunch of ones and zeros stored in memory and translating that over to text characters that we actually read. There are a variety of ways to encode text, and we have it's our choice how we choose to store them, and sometimes the files are stored in a different way. So all of those are options. There's also some other things in here for sort of what to do if you fail or to open a file or something like that. All that being said, what this function does is it opens something that a file that you give it the path to, and that's all. By default, this should open it in read mode. There are other ways to open, other ways you want to open files. Namely, sometimes you want to open them in write mode. If you can understand what that one of those is, opening the file such that you are intending to only read the information, you're not able to modify anything inside of the file. And then write mode, which you will be intending to modify the file. There is also append mode, which is pretty important. Write mode is going to write over the file. So if there is text inside of it, it's going to write over that text. Append mode instead obviously adds to the end of the text on a file for text files. Write mode won't let you do any of those things, but by default this will open this as read. From there we now have this reference right here to the file, and we are going to infile dot read there is an option here, and we are going to read, where are we? There we go. There are a variety of ways that you can choose to read. I usually do, or I prefer to read line, which will read the first line that's referenced and give you that bit of text back. There we go. And let's assign that to a variable, and let's call it line 1 equals. And you might ask, well, what if your text is only, or How does it know that you've gone to the end of the line? Well, that is done with another special character called the new line character. And we will talk about a bunch of those special characters when we get to the text processing part of the course. It's worth having a big long discussion about because there are lots of these special characters that do various kinds of things. But let's print what that first line is. Line 1. And then we will, this is sort of a key step here. We are going to close the file. And we will do that by, actually, you have to reference this file that we opened. So just like I referenced it right here to read the line, and that should do it. What is the syntax here? Oh, I was right the first time. So this is the slight danger to working in an IDE is sometimes, you know, it will highlight something that's not a problem and you'll start investigating it and trying to figure out what's wrong, and then lo and behold, you'll find out it's not a problem. So that's what just happened there. All right, so that was a sort of big long explanation for something that's rather simple, right? We've shown that you can output text, you can input text on the console, and all this is going to do is Python's going to come down here. It's going to say, as we've sort of discussed in variables, it's going to read this text, not know what that text means until it gets to the equal sign, and then it will say, oh, this text is a variable. Okay, so we have a variable named infile. What is the value of infile? Well, it is the value of infile is this is a opened file on your computer. This is what's called an object. Now it can kind of be any kind of fancy complicated bit of data, just like the string and the integer and the data types you referenced earlier. It needs to occupy some bit of memory, but an object, unlike those primitive data types, an object can be enormous. It can be, you know, like gigabytes and gigabytes if you wanted to, and it's this amount of memory it takes up is sort of defined by whoever wrote the class for the object. But that's a lecture on its own for later in the semester. But what Python does here is it gets a variable. You're pointing your variable at this open file, and then you're saying, all right, we have another variable now, another new variable. And what is its value? Its value is the first string of text in that open file. And then you're going to print that string of text, and then you're going to close the file. So, all that being said, let's see if it works. So first it's going to ask me for text. I'm just going to enter some random stuff, and we got an issue. All right, so we can't find this text file. So I see it right here. It might want me to do that dot reference actually. And I will explain this in a moment. It still can't find it. So we have two options now. The first of which is going to be, we can ask Python to tell us where where it is in memory so that we can know where our file path is. I'm going to comment out these lines just so that I don't have to keep entering stuff in the command line. Or we can globally reference this. So I'm going to ask Python to tell me where it is, where it's running. The other option is we can probably just tell PyCharm where we want to run. Python might be running right here because this is where the executable is. But let's find out. I don't actually remember what the syntax is for that off the top of my head. Python is very easy to find out. That's the nice thing about Python. Print run location. So you will see some nice. All right, so what we will do is do get CWD, and there are obviously a lot of different ways that you can write this. There's always a million different ways to write pieces of code, but so let's see, print, let's see if this works. Get CWD. And what is it going to tell me? It's going to tell me that it doesn't recognize that function because it comes from OS, an external library. Oh, this is old documentation. Well, the other option we can do, let's see, os dot ls, no, pwd. That is actually the Linux way to do that. Well, you get to see some. This might also be a keyword that we can use for this. Let's see. So in Python, you'll see frequently you'll see these special double underscored keywords that usually store certain important information. And okay. So now we got to know. So you can see that it is living in this file. Why is that not loading, actually? Oh, my God. Well, I could cut this segment out of the video, and I might, but this is actually a really good sort of first example of how bugs in code are troubleshooted and where bugs come from. So all of this work that I just did to try to figure out what was going on here and why I couldn't read in the file, we discovered it. And let me tell you, this is probably the most common bug that you can get, which is you're not actually telling the computer to do what you want. This file, test.txt, doesn't exist because my file is text.txt. Yay! So if we correct that and save this, there you go. We read in the first file, the first line of my file. There it is, right there. And now let's do another file operation. So this is the basics of how you read information out of a file. So I did read line, which will do a line. There's also read. There's read lines. And these are slightly different. Read gives you an option of how many characters you want to read out of your file. So if you really need a specific little bit of your file, that's the best sort of fastest way to do it. Read line obviously is there's some circumstances where you'd want that. Maybe if you just want a specific line, you can pick that, but with the argument in read line. But the sort of danger is, what if your file is 50 gigabytes and it's all one line of text? Well, you're gonna wait while it loads something. Read lines will read all of the lines from your text, and the danger there is if your file is gigantic, it's also going to load that all into memory, and if it's 50 gigabytes, you're going to wait for that all to read. We will talk about the other ways to sort of read a few lines or read groups of lines. But we are not going to talk about that today because it requires a little bit more knowledge of the programming language to be able to do that. So for now, you can just use a nice little read line function. All right, with that all being said, you learned file input, and now let's talk about file output. So let's make a new variable, out file. So this is a pretty common naming convention here, is in file and out file. Up to you how you do things. Same way we did the other one, open and then a reference to. I'm going to do a new file because I don't want to overwrite my text file. I want to use that later. So let's say out file dot text. So what this is doing is it's going to read this out file, but we want to do something a little different here. If I just left it like this, it would open the file for reading, but there's no out file to read yet. So we will need to add an additional argument in this function here. And this is the file mode. We are going to do W, which is write. I believe, I can't remember if Python actually has a different sometimes some programming languages have a different syntax for write versus create, which means essentially write an existing file or create a new file and then write to it. We'll find out in a moment if Python is one of them. When you learn a lot of programming languages, it's easy to get these things mixed up over time. But so what is this going to do? It's going to open a new file for writing, and what I want it to do is create it right in the same directory, and we're going to outfile dot write. So just like we did a read line here, we're going to do write. And you don't need to do a write line because it should just take it as this string of text as a whole line and move on. So let's write that little string of text that I recorded from the last file as the text we're writing to this file. And just like earlier, we are going to, you have to close that file when you're done with it. It may seem weird because you'd say, well, maybe it should close when my program ends, and that's true. But what closing does when you're in a program is it ensures that it closes. There are times when you might write a program that could be doing, could open a file and do something and go do some other tasks and still be writing to that file when your program ends and cut off the stream of text that you're writing and corrupt your file. So you should always be sure to manually sort of open and close files within your programming language or your scripts so that you know that they're actually getting freed from memory and not corrupted. With all that being said, let's see if we write an output file or if we get an error. And it looks like everything finished, and lo and behold, we have a new out file here. Does it have stuff in it? It does. It has that single line of text that we read in from before. So now you can, now you have the ability to do what's called persistence. What does that mean? It means you can write a piece of code that somehow references information from before it was created and stores information for after it finishes. You can now iterate and work from information that you have stored for you and write information for yourself to reference later. You just became a million times more powerful in your programming. Congratulations. Once again, I'll remind you before I finish this little lecture that this code as it is, you'd fail if you submitted this, so you should always throw a whole bunch of comments in your code so that I don't fail you. So I'll show you how to do this one more time. I'm not going to do this again in another lecture, so keep this in mind. So, what am I doing in here? Read text in from the console and store it to var1. There we go. Let's add a line of text here and say read a file from the local directory and we're going to add more. Read the first line of in file close in file, and we're going to read, or rather open a new file for writing text to persistent memory. And you see what I'm doing here is anytime anytime I'm doing a new little byte, a little chunk of operations, I'm putting a comment in. This is a really big overkill. and it will only become more of a headache as you move on and get better at code. But um, if you get really used to doing this sort of thing, then you will never have to go back to 2-year old code you wrote and have to and like rip your hair out trying to figure out why you did what you were doing, why that thing that you did worked. Um, you will always have this sort of record of exactly what you're doing. And it's partially a service for yourself if you go back for coding and in reference to your old code, but it's also a service for anybody that you might share your code with. Um, it is so unbelievably hard to understand other people's thought processes when you read their code, and these little sort of snippets are gold mines if people actually do them, to understand why people did what they did. And without them, I mean, you can always figure it out, but it becomes borderline impossible to figure out very complicated code without it. So, always good to check that the code still works, and it does. And we're all happy. Thanks for watching. You now know how to do some IO in Python. Have a good day.